everyone. So before you start to watch the entire video, I request you all to go and observe the lead of the pencil and write down all the inferences in regard to the physical properties of that pencil lead. Okay, so now I hope that you have noted down some of the physical properties of that pencil lead. So I want you all to please match with the physical properties that are already noted down here or are already mentioned here. Okay, so the first thing that you will observe for the pencil lead is that it is grayish black in color, right? So what is the color of the pencil lead? It is grayish black in color. Apart from this, the pencil lead is an opaque substance. Now what is an opaque substance? We know that there are three types of substances. The first one being the transparent substance. Now what is a transparent substance? If light is incident over this transparent substance, it allows the light to pass through it and objects on the other side are clearly visible. So this type of substance is known as the transparent substance. Okay, the second one being the translucent substance. Now what is a translucent substance? Okay, they allow the light to pass through them, but objects on the other side are not clearly visible. So the objects on the other side are not clearly visible. If we talk about opaque substance, they do not allow the light to pass through them. So your pencil lead is an opaque substance. Okay guys, now the next thing that I want you all to do is just remove the wooden case of the pencil and take the pencil lead in your hand and try to roll it. So what you will observe? You will observe that that pencil lead is too slippery and smooth in nature. Okay, so that pencil lead is too smooth and slippery in nature. And the next thing that you can observe is, let's suppose this is your pencil lead, and as soon as you apply the force on this substance or this lead, it will be broken down into two pieces, which suggests that this substance is too brittle in nature. And apart from this, why I have written this substance is soft in nature? Because as soon as you start to abrade or scratch the surface of this pencil lead, you can easily scratch or abrade the surface of this substance. That's why this substance is too soft in nature. Okay, and the next thing is, as soon as the light is incident over this graphite, the surface of this graphite appears too shiny, which suggests that this substance is lustrous in nature or it possesses some luster. Okay, so we have discussed about this pencil lead. Now what is this substance? This substance is nothing but your graphite. Okay guys, and this word graphite is derived from the Greek word graphene. Okay, this is derived from a Greek word graphene, which means to write. Okay, so this pencil lead is nothing but your graphite. So what is a graphite? It is graphite is a crystalline form of carbon. It is a crystalline form of carbon. So what does the word crystalline means? See, crystalline means when all the particles of a substance are arranged in a definite pattern or are following a definite pattern which gives them a definite structure is known as a crystalline substance. So let's suppose this is the layer A, this is the layer B, so again this is layer C. So they are following a definite arrangement of these layers. Okay, this is layer A, this is layer B, this is layer C. So this layer A is entirely similar to this layer C. So graphite is the crystalline form of carbon, and the word crystalline means that all the particles are in a definite arrangement which gives this substance a definite shape and size. Okay, and the word graphite is derived from the Greek word graphene, which means to write. Now if we talk about the older terms of this word graphite, or archaically this word, or in the older terms this word was known as the plumbago, or it was also known as the black lead. Okay, plumbago or the black lead. Now this mineral is found in Sri Lanka, Siberia, and in our own country, that is India. So in India it is found in the states of Jammu and Kashmir, in Rajasthan, and in the state of Bihar, and some other states are also there like West Bengal and etc. Fine. So how this natural graphite is formed? See, we We will also study about the natural graphite, and we will also study about the artificial, synthetic, or the man-made graphite. So how this natural graphite is formed? See, this natural graphite is formed when your carbon is subjected to high heat and pressure. So when your carbon is subjected to the high heat and pressure, it is converted to the graphite, and it is usually found in the metamorphic rocks. It is usually found in the metamorphic rocks. It is usually found in the metamorphic rocks. Okay. Apart from this, if we talk about the artificial preparation of graphite, so this is the artificial method by which your graphite is formed, and this process is usually carried out in an electric furnace. Now what does the word electric furnace means? See, whatever heat is provided in this electric furnace is just because of the electric filaments or electric components that are present there inside the electric furnace. So as soon as the current is passed through all the electric components in this furnace, so they generate some heat, and because of this heat, the reactions are carried out in this electric furnace. So what is the reaction in this electric furnace? So we have to use this silicon dioxide. Now this silicon dioxide is nothing but your sand. So the chemical formula of sand is silicon dioxide, and we are using this powdered substance which is known as coke. See, the coke is an amorphous form of carbon. Okay, so we are using the powdered form of coke and small amount of sand, and when they are heated to 3000 degrees centigrade in this electric furnace in the presence of ferric oxide, they will form carbon monoxide and silicon carbide. And when this silicon carbide is further heated, it is converted to silicon and carbon, and this carbon is nothing but your graphite. Okay guys? Okay guys, so whatever physical properties we have discussed at the beginning of this video, so reason for all those physical properties will be explained using the structure of graphite. Okay, so I have drawn a part of the structure of the graphite. This is the part of the structure of graphite. This is not the entire structure, it's just a part that I have picked and draw here, right? So this is the ball and the stick model of graphite. I will explain what is a ball and stick here. So this is the ball and the stick model of the graphite. Apart from this, the individual layers, that is layer A, layer B and layer C, these individual layers are known as graphene. So these individual layers which are stacked over each other to form the entire structure of graphite are known as the graphene layers. Layer A is known as graphene layer, layer B is also graphene layer, layer C is also graphene layer. So these layers stack over each other to form the entire structure of graphite. Okay. Apart from this, the structure of these layers is called as the honeycomb structure. It looks similar to the honeycomb, so that's why it is known as the honeycomb structure. Okay. Fine. Apart from this, I have mentioned that this is a ball and the stick model. So if you'll observe this ball, okay, this is a ball and this is a stick. Okay, so this ball is nothing but your carbon atom, and this stick is nothing but the covalent bond that is present between these carbon atoms. Okay, so this ball is nothing but the carbon atom, and this stick is the covalent bond that is present between the carbon atoms. So if you observe this carbon atom, so it is bonded to 3 other carbon atoms. This is first carbon, this is second carbon, this is the third carbon atom, and we know that each carbon has 4 valence electrons. So if this carbon atom is bonded to 3 other carbon atom, means there is one free electron. Okay guys, and just because of this free electron or this delocalized electron, graphite conducts electricity. Being a non-metal, graphite conducts electricity. So I think now you know the reason why graphite conducts electricity. Graphite conducts electricity just because of this free electron or the presence of this delocalized or free electron. So why this free electron is there? Because each carbon is bonded to 3 other carbon atoms, and carbon has 4 valence electrons. So this this electron is the free electron, right? And one more important thing, this electron won't jump from this layer to the layer B or to the layer C. It will only move into the layer A. If you are talking about the electron of the layer A, it will move only into layer A. So every carbon has a free electron or the delocalized electron which move into its own layer. Fine. So now If we talk about the bond length between these carbon atoms, now what is the bond length? The distance or the average distance between the nucleus of this carbon atom and the nucleus of this carbon atom is known as the bond length. Okay, so what is the bond length here? The bond length here is 0.142 nanometer or 142 picometer. Okay, and the bond is covalent bond. The bond is covalent bond. That's why the melting point of graphite is too high. The melting point of graphite is too high just because the bond that is present between the carbon-carbon atom is known as the covalent bond, and the bond length is 0.142 nanometer. Now if we talk about the bond length or the distance between these two layers, so the distance between these two layers is 0.335 nanometer. So I think you can easily observe the distance between two carbon atoms is 0.142 nanometer and the distance between two layers is 0.335 nanometer, and the force of attraction here is van der Waals force of attraction. Just remember that between carbon and carbon atom the bond is covalent bond, but between the layers the force of attraction is van der Waals force of attraction, so which is the weakest force of attraction, and this is the reason why your different layers slide over each other, and this is the reason why graphite acts as the lubricant. So why graphite acts as a lubricant? Because the layers slide over each other. And why the layers slide over each other? Just because they have weak force of attraction, that is the van der Waals force of attraction between them, with a bond length of 0.335 nanometer. I think till this point everything is clear regarding the structure of graphite, right? So now we will discuss some of the uses of graphite. Okay, so graphite is used to make the artificial diamonds. Okay, so if you heat the graphite at 3000 degrees centigrade in the absence of air, so you will get diamond. Okay, so as soon as you heat graphite at 3000 degrees centigrade, means there is a high heat and pressure and absence of air, that is absence of oxygen, you will get this diamond, right? And we know that the graphite is also used to make the pencil leads. And why it is used to make the pencil lead? Because it leaves a black mark over the paper. Why it leaves a black mark over the paper? Because the layers slide over each other, and this is also the reason why you are easily able to sharpen the graphite, right? Just because the layers have the van der Waals force of attraction, that's why they easily slide over each other and you are able to sharpen it, and they also leaves a black mark over the paper. That's why it is used to make the pencil lead. Why it is used as a lubricant? The same reason that we have discussed above. Why it is used as a lubricant? Just because the bond length between the two adjacent layers is 0.335 nanometer, which is twice to the bond length that is present between the carbon and carbon atoms in the graphene layers, right? And apart from this, the force of attraction is the van der Waals force of attraction. So just because of this weakest force of attraction present between the different layers of carbon, these layers slide over each other. They slide over each other. That's why they are used as a lubricant, a solid lubricant. Graphite is also used to make the electrodes. So we also use the smelting process for aluminium. So if electricity is used in the smelting process of aluminium, then we use the graphite electrodes, or in the electric furnace. Okay, electric furnaces, we also use the graphite electrodes. So these are some of the uses of the graphite: to make the artificial diamonds, to make the pencil leads, used as a lubricant, used to make the electrode. Okay guys, I hope you like the video. Kindly please tap the like button, share this video with your friends, and don't forget to subscribe my channel Knowledge Acharya. And guys, please press the notification bell, as whenever I upload a video, you will get the notification of my video. And please write your comment in the comment section. If you have any queries, I will solve them. Thanks a lot.